Drop a raindrop into Lake Superior. How long before that water reaches Lake Erie? Days? Months? It is one of the most surprising numbers in hydrology, and you can compute most of it from a single national dataset. First, the route. Out of Lake Superior through the St. Mary's River, down the length of Lake Huron, through the St. Clair River into Little Lake St. Clair, then down the Detroit River, and into Lake Erie. Notice something about this 1,000-kilometer journey. Only about 200 kilometers of it is actual river. The rest is lake. Hold that thought. The rivers we can compute directly. The National Hydrography Dataset carries, for every map channel in the country, an estimated mean flow and velocity. Reading our archive, the St. Mary's runs 95 kilometers at about 0.7 meters per second, carrying 2,300 cubic meters every second, 1.6 days. The St. Clair, 58 kilometers, 6,000 cubic meters per second, under a day. The Detroit, 48 kilometers, another 2/3 of a day. Every river on the route, end to end, about 3 days. But a lake is not a river. Water entering a lake mixes into a volume that drains slowly, and the average delay is simple division, volume over outflow. Lake Superior holds 12,100 cubic kilometers, and its outflow is that same 2,300 cubic meters per second we measured in the St. Mary's. Divide, and you get roughly 170 years. Lake Huron, 3,500 cubic kilometers, about 19 years. Lake St. Clair, small and shallow, 6 days. Now stack the whole journey. Rivers, 3 days. Lake St. Clair, 6 days. Lake Huron, 19 years. Lake Superior, 170. In total, an average drop takes roughly 190 years to travel from Lake Superior to Lake Erie, about 2 centuries. The rivers, the only part you can actually watch flowing, account for 0.005% of the trip. And what if the drop starts in Lake Michigan instead? Michigan has no outlet river at all. It drains through the Straits of Mackinac, about 8 kilometers wide, where the hydrography archive reads roughly 1,500 cubic meters per second flowing into Huron. The two lakes stand at the same water level. Hydraulically, they are one system. So, for 1,920 cubic kilometers, divided by that flow, about 100 years. Add Huron and the rivers, and a drop from Lake Michigan reaches Erie in roughly 120 years. Faster than from Superior, but only by decades. One honest caveat, that is an average, and the distribution around it is enormous. A drop that stays near the outlet current can make the trip in a few years. A drop that mixes into Superior's deep basins can wait 500. And many drops never make the trip at all. They leave by evaporation instead. But the average carries the message that matters. Whatever enters Lake Superior today, the Great Lakes will remember for centuries. A continental water system, timed with a hydrography dataset and long division. The river is the fast part, the lakes are the memory. And both are physics you can compute.